Welcome back, everyone. If you're currently grinding away for your Network Plus or CCNA certifications, I know firsthand that abstract networking concepts can feel like a total maze. But don't worry, because today, in this explainer, we are completely demystifying network layers. We're going to break down exactly how data travels across a network, giving you the clear, structured knowledge you need to absolutely crush those exams.
Let's take a quick look at our exam prep playbook for today. We'll be covering networking basics, the 7-layer OSI model, data units and encapsulation, the TCP/IP model, comparing OSI and TCP/IP, and finally, TCP versus UDP. All right, let's get you test ready. Starting off with Section 1, the networking basics and building the physical connection. So before we can even talk about global routing or complex applications, we have to start at the absolute bottom. It really all begins with a super simple but completely fundamental question. Once an Ethernet cable is actually connected between two computers, or maybe they just share the same local Wi-Fi signal, how do they actually recognize who's on the other end? I mean, even though they're physically linked up, they still need a way to identify one another just to start a basic conversation, right?
Well, that brings us right to the MAC address. Think of this as a unique hardware identifier that every single network device is practically born with. When devices are directly connected on the same local network, they use these MAC addresses to recognize each other. It's kind of like their unique fingerprint. And when you scale things up, say you add a switch to connect 100 different devices in an office building, that switch actually reads the destination MAC address on every single request so it can route traffic directly to the right machine. It solves that local communication problem perfectly.
Moving right into Section 2, the 7-layer OSI model, which serves as our theoretical framework.
Now, to understand how data moves globally across completely different networking technologies, we really need a universal framework. Enter the Open Systems Interconnection, or OSI model. Created by the ISO, it's basically a way to think about computer networking in logical abstraction layers. Notice how it stacks from the physical layer at the very bottom, that's layer 1, where our cables and raw signals live, all the way up to the application layer at the top at layer 7, which interfaces directly with your network processes. Every single layer has its own specific functions, and they all work together in a very strict, specific order.
For the exams, you absolutely must memorize this exact sequence. Seriously. These two mnemonics are going to be your absolute best friends on test day. If you prefer to learn it from the bottom up, just remember, please do not throw sausage pizza away. I know, it's totally ridiculous, but trust me, it sticks. That gives you physical, data link, network, transport, session, presentation, and application. Or if working from top to bottom makes more sense to your brain, just think all people seem to need data processing. Write these down, seriously, they will literally save you when the clock is ticking on exam day.
All right, Section 3, Data Units and Encapsulation. Consider this your exam's secret weapon.
This is a massive focus for technical exams, and it's all about how data actually changes names and forms as it travels vertically through our layers. We're talking about Protocol Data Unit, or PDU mapping. It's actually kind of fascinating how the data transforms. Down at the very bottom on the physical layer, information is literally just ones and zeros, we just call them bits. But as you move up to the data link layer, those bits get organized into frames. At the network layer, they become packets or datagrams. Moving up again to the transport layer, they turn into segments. And finally, once you hit the top 3 layers, session, presentation, and application, it's just broadly referred to as data. Examiners absolutely love testing this exact mapping, so make sure you lock this in for sure.
Next up, Section 4, the TCP/IP model, which is the actual implementation of the Internet.
So, with that theoretical foundation locked in, it's time to shift our focus to the real world, which really begs a pivotal question. If the OSI model is basically just a reference framework used for teaching, what does the Internet actually use in real life? Because, believe it or not, there are no real working implementations of the full 7-layer OSI model on modern operating systems. Crazy, right?
Well, the answer is TCP/IP. That stands for Transmission Control Protocol and Internet Protocol. The roots of this model actually trace all the way back to the U.S. Department of Defense and the ARPANET project back in the 1970s. And amazingly, it evolved into a highly practical 4-layer operational model. Today, it serves as the actual backbone protocol suite of the modern Internet. It is literally the protocol suite we use every single day to do, well, everything online. Within this model, IP handles the datagram routing, getting the data to the correct destination, while TCP takes on the responsibility for reliable, higher-level delivery and error checking.
Moving on to Section 5, Comparing OSI and TCP/IP. This is the ultimate face-off.
We really need to put these two heavyweights in the ring together, because directly comparing them is practically guaranteed to pop up on your exam. What's super interesting is how the 4-layer TCP/IP stack essentially condenses those 7 OSI layers. If you look at the top layers, the application, presentation, and session layers from OSI are efficiently merged into just a single TCP/IP application layer. The transport layers, they align nicely across both models. Then the OSI network layer becomes the internet layer in TCP/IP. And finally, the bottom 2 OSI layers, data link and physical, are just combined into a single network interface layer. It really shows how TCP/IP simplifies all that theory into something incredibly practical.
Let's walk through some of the strict, highly testable differences between the two. First off, OSI is a generic protocol-independent reference tool, whereas TCP/IP is a very practical, protocol-dependent implementation. You definitely need to know the layer counts for the test. OSI has 7, TCP/IP has 4. At the transport layer, OSI guarantees packet delivery by definition, but in TCP/IP, the transport layer itself doesn't guarantee delivery at all. It relies entirely on specific protocols, like TCP, to handle that reliability. And finally, the OSI network layer provides both connection-oriented and connection-less services, but the TCP/IP internet layer is strictly connection-less.
And that brings us to our final module, Section 6, TCP versus UDP, our transport layer heavyweights. Let's zoom in on Layer 4, the transport layer, to compare the two most critical communication protocols you absolutely have to know. Let's just do a rapid-fire breakdown here. So TCP is connection-oriented. It creates a virtual connection and is highly reliable because it uses acknowledgements. Basically, if a segment gets lost, TCP just asks for it again. The catch, it's slower because of all that extra overhead, which makes it perfect for things like web browsing, email, and file transfers, where accuracy is totally vital. UDP, on the other hand, is connectionless and unreliable, meaning absolutely no acknowledgements. It literally just fires data at the target and hopes for the best. But because it completely drops all that overhead, it is incredibly fast. This makes UDP the absolute undisputed champion for gaming, live streaming, and VoIP calls, where a dropped frame is way better than a delayed frame.
So pop quiz time. If you're watching a live stream and you desperately need raw speed over perfect reliability, you now know UDP is your champion. But here's a thought to leave you with. What happens when modern applications demand the lightning speed of UDP and the flawless reliability of TCP at the exact same time? How do today's tech giants solve that seemingly impossible puzzle? Keep that bouncing around in your head as you prep to crush your technical exams. Trust your mnemonics. You've got this, and we'll see you on the next explainer.